By 2026, 85% of enterprises have moved past testing and into full deployment. AI systems now draft live contracts as standard practice. This chart tracks a significant shift. Over 2 years, hallucination rates for top frontier models dropped from roughly 15% to less than 1% on factual queries. Yet, despite that drop, business losses tied to AI hallucinations reached $67.4 billion this year. Most AI-driven legal errors now come from practicing attorneys rather than self-represented litigants. In the first quarter of 2026 alone, sanctions against lawyers for AI-generated false citations reached a record $145,000. The hallucination problem hasn't disappeared, it has fragmented. A model's safety now depends on how its specific failure mode aligns with your professional risk. Software buyers looking at public leaderboards to find the most accurate model often find contradictory data. The numbers change depending on the specific test. Gemini 3 Pro illustrates the confusion. It scores a 0.7% hallucination rate on basic summaries, but spikes to 88% on hard knowledge questions. Developers make a deliberate choice. They build for knowledge expansion, guessing to surface insights, or epistemic humility, admitting they don't know. Mathematically, you cannot optimize for both. Pushing a system to generate maximum insights forces it to sacrifice strict factual safety. Model selection is about more than raw intelligence. Every deployment requires you to match an AI's specific failure mode to your professional risk profile. To handle complex logic, the industry introduced reasoning models. They are designed to explore multiple logic paths before providing an answer. But these advanced models often struggle with basic, grounded tasks, like summarizing a 50-page vendor contract. These models tend to overthink. Instead of just extracting text, they draw complex inferences and insert new insights. In a strict summarization test, those unprompted additions are counted as hallucinations. This is known as the reasoning tax. Data shows that reasoning models often hit a 10% error rate on basic summarization, performing significantly worse than cheaper non-reasoning models. Paying for a smarter AI can actively sabotage your workflow if your job requires strict fidelity to a source document. When an AI model hits a gap in its training data, its behavior depends entirely on the provider's philosophy. Gemini 3.1 Pro attempts to answer almost every query. This gives it high accuracy scores, but it also means that when the model is uncertain, it fabricates a plausible answer 50% of the time. If you want those insights, you have to pay for them with an extensive human-in-the-loop review pipeline. Every claim must be verified because the model won't warn you when it's guessing. Contrast that with Claude 4.1 Opus. It takes a safety via refusal approach, declining to answer 18.7% of the time. This drops its hallucination rate on uncertain questions to near zero. For high-stakes compliance work, a model that refuses to answer is more useful than one providing a plausible guess with a high chance of being dangerously wrong. If you need to guarantee the AI isn't pulling in outside fabrications, you use a closed system like Google's Notebook LM. It uses source grounding, meaning the system is restricted to the specific PDFs, docs, and transcripts you upload. It cannot use its general internet training data to answer. When it answers, it provides citation chips linking directly to the specific paragraph in your file, allowing you to verify exactly where the information came from. This restricts capability. A walled garden can't brainstorm broad industry trends or pull today's live web events. It only knows what you give it. But by sacrificing that broad, general creativity, you effectively eliminate the risk of fake citations for closed corpus research. This decision tree maps your model choice directly to the stakes of your job. The first question is, what is the penalty for a wrong answer? For legal and compliance professionals, the high penalty branch routes directly to Claude 4.1 Opus. Because Claude is calibrated to refuse rather than guess, it won't invent case law or statutes. It protects you from professional sanctions by admitting when it lacks the facts. That same risk profile applies to students and academic researchers facing severe penalties for academic dishonesty. Using a strictly grounded tool like Notebook LM guarantees you are studying the actual theories from your syllabus rather than an AI-invented concept. In high-penalty domains, you trade the AI's creative freedom for factual certainty. Medical and financial fields present a unique challenge. A wrong answer carries life or death consequences or high-stakes financial risk, but the work requires immense knowledge breadth. You cannot restrict these workflows to a walled garden. You need the deep stored knowledge of models like Gemini or GPT-5. To mitigate risk here, you enable live web search or connect the model to a verified internal database to ground its answers in live data. Data shows that simply enabling web access drops a frontier model's hallucination rate by 73 to 86%. This setup provides the capability you need, but it requires you to build human verification layers to catch the remaining edge cases. Look at what happens when the model gets it wrong, and choose the architecture that respects those professional stakes.